Okay, the next step now is we are going to derive the rate of equation for overall reaction. Untuk kita derive the rate reaction tu, we have to define first. Is it the overall reaction is controlled by reaction kinetics? Is it controlled by reaction kinetics? Or is it controlled by mass transfer? So ayat lainnya, is it the overall reaction is reaction kinetic limited or is it the mass transfer limited? Untuk kita derive the overall reaction tu, kita kena consider, kita kena assume the catalyst to be non-porous. So kalau kita consider or assume the catalyst to be non-porous, so meaning that the reaction only happens on the external surface of the catalyst. So kita tak untuk you punya syllabus, kita tak perlu nak fikir sampai internal reaction happens on the internal catalyst. So meaning that kita tak perlu nak ambil kira the CAX. Kalau you masih ingat, the concentration profile within the internal catalyst catalyst surface is CAX kan, so kita tak perlu nak derive sampai guna concentration profile of CAX ni, kita hanya guna CAS. So bermakna kita just assume that the reaction happens on external surface of the catalyst only. Okay, jadi saya akan details out what are the assumptions and what are the considerations untuk kita derive. The first that you have to assume that the reaction happens on external surface of catalyst only. So meaning that the external surface that is reactive. Kemudian we have to assume that the reaction is at steady state. Steady state means there is no accumulation on the catalyst surface. Bermakna the rate of transport to surface is very efficient, which is it's going to be the same as the rate that happens on the reaction of surface. So apa maksud ni? Ini bermaksud rate yang berlaku dekat step 1, 2, 6 and 7 is equals to the rate that happens on 3, 4 and 5. Bermaksud juga rate of mass transfer limitation is the same as rate of reaction that happens on the surface ataupun rate of kinetics. Okay. Another assumption is the reaction is going to be first order irreversible, and let's say the reaction is on a single spherical pellet and we have to use the radius R. Jadi the total rate of reaction on the external surface of the pellet adalah kita menggunakan this equation, in which this equation, this term is referring to mass transfer rate. So yang ini adalah referring to reaction kinetic rate. Sebelum tu saya pernah cerita that reaction kinetics on the surface of catalyst adalah ini. Okay, R double apostrophe is equals to K double apostrophe times concentration of catalyst surface. So term yang ini kita boleh masukkan dalam this one So dia jadilah this one. So this equation equals to rate of transport or mass transfer equals to rate of reaction that happens on the catalyst surface. Okay, still we are in this equation after the consideration of three assumptions before. Jadi yang ini adalah terms untuk spherical of catalyst. Kita assume that the catalyst in spherical shape. So kalau spherical, kita akan guna geometry ini 4 times pi with this radius to the power of 2. This area ni adalah untuk rate of mass transfer ataupun rate of transport to the surface of catalyst, which is equals to rate of surface reaction, rate of reactions that happens on the surface. Jadi term yang ini adalah merujuk kepada step 1, 2, 6, 7. So term yang ini adalah merujuk kepada step 3, 4, 5. Okay. Kemudian once you have this equation in which that yang ini adalah merujuk kepada concentration profile of bulk, concentration profile difference of bulk with concentration of catalyst surface. So daripada sini, kalau you ada term this side 4 pi r kuasa 2, and on the left side also you have 4 pi times r to the power of 2. So bermakna you can cancel out this, right? So when you cancel out this, jadi tinggal term yang ini saja. Jadi from here you can actually go to this step and you can actually derive this term. Bermakna concentration of catalyst surface is equals to concentration of bulk of reactant at bulk fluid divided by 1 plus rate constant from surface reaction divided by mass transfer coefficient. Okay, so sebelum ni I have introduced to you the reaction on the catalyst surface, and previous slide you already maybe been introduced on how to derive the concentration of on catalyst surface, which is equals to concentration of reactant at bulk fluid divided by 1 plus rate constant double apostrophe divided by mass transfer coefficient ni. Jadi this term maybe you boleh masukkan dalam ni. So bermakna your reaction rate on the catalyst surface jadi begini. You akan dapat this term. So kalau you simplifykan K over 1 plus K double apostrophe divided by transfer coefficient as this one, K efficiency, K effective. So you akan dapat term U SR equals to apa R double apostrophe R double apostrophe you boleh simplify as K effective sorry so slow, K effective times concentration of reactant at bulk fluid. Okey, daripada term ni nanti kita nak tengok siapakah yang rate limiting. Is it reaction kinetic is the rate limiting, or is it mass transfer is the rate limiting? Okay, so previously, let's say that you have derived this rate reaction on the catalyst surface as to be this one. So kita nak tengok sekarang which one is the limiting factor. Is it reaction kinetics, which is referring to step 3, 4, 5, or the mass transfer, which is referring to step 1, 2, 6 and 7. Caranya adalah jika your value of K apostrophe double apostrophe is less than diffusion rate, mass transfer coefficient rate, sorry. If K double apostrophe is less than mass transfer coefficient, less maksudnya nilai K ni adalah lebih besar. Nilai K ni adalah lebih kecil daripada mass transfer coefficient. Jadi kita boleh assume term yang ini to be 0. So kalau term yang ini to be 0, so dia akan jadi this term. K double apostrophe times concentration of A at bulk fluid divide by 1. Sebab yang ini kosong kan. So reaction kinetics U, reaction U adalah governed by reaction kinetics. So meaning that the reaction kinetic is the limiter. Tetapi if the value of mass transfer coefficient is less than K kinetic, K double apostrophe is K kinetic. So bermakna value of mass transfer coefficient is really small. So bermaksud step limiting, the step of mass transfer is sangat slow, kan? So kita pernah define sebelum ni, step yang slow adalah the one that govern or control the overall reaction. So bermakna reaction rate U adalah equals to diffusion mass transfer coefficient times CAB. So it is the mass transfer limited. So that's the end of the subtopic for this slide. Thank you.